Hello everyone. In this tutorial, I am going to take my time to explain intuitively the transformation of sine and cosine graphs. I am going to treat tangents separately. Before we start talking about transformation of these graphs, let's see how we can construct the mother functions, sine and cosine. Alright, but always your unit cycle is very important. So here is my unit cycle. I'm going to use only these 5 angles. We have 0 here. If you come down here, you have pi over 2 or 90 degrees. This is pi or 180 degrees. This is 3 pi over 2 or 270 degrees. If you come down here, you have 2 pi. This is a complete cycle in unit cycle. But on a graph, this is what we call a period. A period means complete cycle before you take a turn, because we have other coterminal angles. This is what we call period. Then you can count this angle clockwise, thereby encountering what? Negative angles. If you come like this is going to be negative 90 degrees, right? Negative pi divided by 2. This is going to be negative pi. This is going to be negative 3 pi divided by 2. And lastly, if you come down here, this will be negative 2 pi. So let's start. I would like to start by constructing y equal to sine x. Sine x is the mother function. So x and y axis. Remember that x axis represents the domain from negative infinity to positive infinity. Then the range will be the values of y. Remember, the least you can obtain is negative 1, and the highest you can obtain is positive 1. Therefore, the range is from negative 1 down to 1. All right, I would like to start by writing the period. One complete cycle to this direction is 2 pi. And if you follow the other direction, you have negative 2 pi. So because we're going to have 0 is the center, right? We have 4 angles, 1, 2, 3, 4. I'm going to divide it by 4. If you take 2 pi, you divide it by 4, you're going to get pi over 2 each. So from here, I have 2 pi, right? From 2 pi, if you come back, you have 3 pi over 2. 3 pi over 2. You have what? Pi. Then you have what? Pi over 2. Then you have what? 0. This is what? Y-axis. But remember, it is from what? Negative 1 down to 1. Then you have negative version of these angles to the left. We have negative pi divided by 2, which is this one. You have negative pi. We have negative 3 pi divided by 2. And lastly, we have negative 2 pi. So let's start by plugging in these values. Let me go to the right first. This is the first value of x. Okay, no, this one. You know, origin is 0, radian. You can use degrees as well. So what happened to the value of y when x is 0? Sine of 0, remember, it is equal to 0. So you place a point here. Then you move to the next one. Sine of 90 degrees or pi divided by 2. Remember, it is equal to 1. So under pi divided by 2, you have 1. This is the maximum. Then sine of 180 is 0. So on x-axis, you have a point. Sine of 270 is negative 1. So here you have negative 1. Then sine of this will be equal to 0. So this is one period. You could have as many as possible. This is just a restriction because I don't have more space. Then coming to the left, we have sine of negative pi over 2, which is also negative 1. So you have a point here. Sine of this will be 0. This will be 1, right? and this will be 0. So you connect the points. So look at the shape. Go to the maximum, down to 0, back to -1, up to 0. This is one period. This is why I have an arrow here to indicate that we have other periods. You come down to the minimum, to 0, back to maximum, down to 0. So this is how a sine of the mother function, sine of x, looks like. So what about cosine of x? If I have y equal to cosine of x, the same thing. The period, the range is from -1 down to 1. Let's start from the origin. What is cosine of 0? Cosine of 0 is 1, so we have our point at maximum. What is cosine of pi divided by 2 is 0. What is cosine of pi is -1. What is cosine of 3 pi over 2 is 0. And what is cosine of 2 pi is 1. So we have something like a U shape. But do not draw a straight line, please. It is curvy. Something like this. This is how the graph of cosine looks like to the right-hand side. Then if you move to the left-hand side, it will look the same thing. You see that? This is just two periods. So the question is, do we always have to do this in constructing sine and cosine functions that are not the mother functions? Because the general form will be like this. And I'm going to concentrate only on the right-hand side because I don't have much space. All my graphs will be from here to other side. The general form of sine function will be y equal to a sine of bx plus c plus d. This is the general form. Y equal to a cosine of bx plus c plus d. Yes? Let me explain this a, b, c, and d. A here is called the amplitude. Remember, the mother function has its amplitude from -1 to 1. So if this a is any other number other than 1, you have to multiply these numbers by that a. And your amplitude is always the absolute value of a. For instance, if you have y equal to -2 sine x, for example, your amplitude a is equal to 2. Always take the absolute value of that number. So you have to take 1 and multiply it by this 2, so your graph will reach after 2. So you see it causes a what? Vertical stretch. But if that number is from 0 to 1, the absolute value of that number, for instance, if I have either y equal to 1 over 2 sine x or y equal to -1 over 2 sine x, you see a is the same thing, 1 over 2. It is going to what? Shrink the graph vertically, because if you take 1 over 2, you multiply by this, it will reach after this level, right? It will shrink in the graph vertically. So this is about a. Then b here, always determine your period, where it is going to end. You see the coefficient of x here is 1, so our period is after 2 pi. But if you have any other number there apart from 1, you have to take that 2 pi, you divide by b, it will give you the period. Exactly the point where you have your complete cycle. Sometimes it will shrink in the graph horizontally, or sometimes it expand it horizontally. Then b together with c will show you the movement, that is the horizontal shift. Sometimes your graph may be shifted either to the left, to the right, or to the left horizontally. So if you take the whole of bx plus c, you set it to be equal to 0, solve for x. That value of x will determine the number of units your graph will be shifted either to the right or to the left. Then D, I've explained that already. It determines the number of units your graph will be shifted above or below. That is vertical shift. So I have some transformations here for us to do today. The first problem here we have is under the effect of the amplitude. So if you have, for example, y equal to 2 multiplied by sine x, the graph will remain the same. Just that it is going to be stretching vertically because the absolute value of this number is greater than 1. And I told you if it is from 0 to 1, excluding 0 and 1, it will compress the graph vertically. So what's happened? Everything I told you remained the same. So assuming I have my y-axis, this is x-axis, we have pi divided by 2 here, we have pi here, we have 3 pi divided by 2, and we have 2 pi. Remember, our period is what? 1 to negative 1. But because we have 2 here, it will multiply these numbers. 1 times 2 will give us 2. So it means that the graph will reach after 2 and it will reach up to negative 2. So you see that it has been stretched vertically. All other points remain the same. We have 0, then to the maximum, which is now 2, to 0, to the minimum, which is now negative 2, and down to 0. Look at it here. You see that? It has now stretched the graph vertically. And this graph may be bigger than this one. It depends on the number of units you have taken on your graph. You know your graph sheet has some boxes. You may say, okay, every 5 small boxes represent pi over 2, or every 4 small boxes represent pi over 2. It depends on the unit. I may have my period just at pi, and the graph will be bigger than this one. It depends on the number of units I have taken. All right, this is the first problem. Then the second problem here is y equal to 1 over 2 cosine x. Assuming that this is 1 and this is negative 1. So half will be here, right? Negative 1 over 2. This is 1 over 2. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. So at maximum, this is now going to be our maximum because of this amplitude. It will go from the highest to 0 to the minimum, back to 0, up to maximum. You see how the graph looks like? So this is all about the amplitude. Then let us talk about reflection. Whenever you have a negative A, if A is negative, it is going to reflect the graph along x-axis. So every point here will drop down here, every point here will go up. It is going to reflect it. So I would like to use this one directly, where we have y equal to negative sine x. You see, the function remains the same, just that this has a negative sign. So every single point other than 0 will be reflected. All values of y will be reflected. Or you can simply take a value of y multiplied by negative 1. So we have something like this. This is negative 1. This is positive 1. This is pi over 2. This is pi. This is 3 pi over 2. And lastly, we have 2 pi. All right. Remember, our graph started from what? 0. 0 will not change because 0 times negative 1 is still 0. Then the next one is at 1 times negative 1 will be what? Negative 1. Then this one is 0. It will not change. Then this one that used to be at negative 1, you see that? It will now be up to positive 1 because it is going to be reflected, and 0 will remain the same. So you see that our graph will now look like this. You see that? this graph has now been reflected because of this negative sign. Assuming we have a number before the negative, maybe greater than 1, it is going to reflect and it's going to stretchen the graph vertically again. Two things. So let's move to the next one. The next one is going to be period. We are going to talk about period now. Sometimes we have an effect on the period. If you have y equal to sine of 2x, I told you that that coefficient of x has an effect on the period. So what will be our period? P is always equal to 2 pi divided by b. But b, you know, is 2 here, which is the coefficient of x, which means that we have 2 pi divided by what? 2, and this is pi. It means that the graph is going to stop at pi. A complete cycle will stop at pi. So we have something like this. 4. I will drop my pi here. Come down here. If you take 2 pi, you divide it by 4, you're going to get pi over 2 each. So this is 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2. This is 4 pi over 2. So if you take this one, you divide it by 4. This one will be pi divided by 4. This is 1 pi over 4. 2 pi over 4 will be pi over 2. 1 pi over 4, 2 pi over 4, 3 pi over 4. You can see that this graph is shorter than this one logically, but it may be bigger than that one because of the scale. The number of boxes I have taken to drop my numbers. All right, so I am done with the period. This is where it is going to stop. So the same shape, everything will remain the same. This is 1, this is -1, 0, maximum, 0, minimum, 0, right? Something like this. So now this is our graph of sine of 2x. Let's move on to the next one. The next one we have cosine of 1 over 2x. Y equal to cosine of 1 over 2x. What will be the period? The period will be 2 pi divided by b, which is 1 over 2. And this is going to give us 4 pi. It means that our graph, one cycle will stop at 4 pi, double of this one. So let me see. So this will be 4 pi. Divided by 4, you have pi, 2 pi, 3 pi. Right? Remember, this is cosine. So the period is now 4 pi. It starts at maximum, down to 0, down to minimum, up to 0, and maximum, something like this. And this is the graph of cosine of 1 over 2x. Let's move to the next one. This is going to be a horizontal shift. Horizontal shift. And I want to let you know that if you see a plus sign here, it means the graph will be shifted to the left. If it is minus, it is going to be shifted to the right. So I have the first one, which is y equal to sine of x minus pi divided by 2. So it means because of this minus, the graph will be shifted to the right. And I'm going to show you how you can create an imaginary y-axis. So we have something like this. The period remains the same, 2 pi, right? So we have 1, 2, 3. Okay, something like this. This is pi divided by 2, 1 pi divided by 2, 2 pi divided by 2, which is pi, 3 pi divided by 2, 4 pi divided by 2, right? 5 pi divided by 2. All right. To determine the horizontal shift, you can always take this and set it to be equal to 0, or you can do that mentally. If you set this to be equal to 0, it means that x will be equal to pi over 2. So come to pi over 2 and draw your imaginary y-axis. It means that this time around you're going to start from here. So where is my, the amplitude remain the same, 1 to negative 1, because there is no any number here. So remember, it started from what? This is sine. It started from 0. So you are going to consider the 0. Remember, it's supposed to be here because it has been shifted pi over 2 units to the right. So the new point will be here. But we are just pretending as if we are starting here. So this is what? 0, then to what? Maximum, back to 0, down to minimum, back to 0. You can see that we reach up to 5 pi over 2. Another way you can do that, you can take your period, which is 2 pi, then you add it to that shift you have, which is pi over 2, just to determine where you're going to stop. This time this will give us 4, plus 1 will be 5 pi over 2. You see that? So this is another way you can do that. So now let us connect all the points together. Maximum down to 0, down to minimum, up to 0. You see that? This is now the graph of what? Sine of x minus pi over 2. And you know that you can continue bringing this down here, down to minimum, right? Okay, at 0 it will reach minimum, then it will go like this continuously. Then let's move to the next one. We have cosine of x plus pi. Cosine of x plus pi. You see that this is going to shift the graph pi unit to the left. So let me give a space to the left since I know it is going to be shifted. So we have, what do we call it? Pi over 2. We have pi here. We have 3 pi over 2. We have 2 pi. This is normal period, right? But this graph is going to be shifted to the left pi unit. So we have negative pi over 2, negative pi. So it is going to be shifted here. So assuming this is our imaginary, I'm going to show you how to draw imaginary axis as well when you start having plus something here. So this is imaginary where we're going to stop. You know, if this is 1, this is negative 1, you have to always start from the maximum, right? So this is where we started. We have maximum here. Then from maximum down to what? Down to 0. Then down to what? Negative 1, which is at 0. Then off to 0, off to 1. Remember that from negative pi to pi is a period, right? So you have something like this. Don't mind my graph. This is how it should look like. And if you continue, it will go like this. You understand? It will go like this. This is what? The graph of what? X plus pi. It has been shifted pi unit to the left. That is just it. Now let us talk about a vertical shift. In the end, I'm going to write an equation, a function in this form to see how we can construct it all together. We have the first one, y equal to sine x plus 3. Sine x plus 3. All right. Assuming this is 1 and this is negative 1. Plus 3 means you should shift the graph 3 units above because it is plus. So from 1, this is our maximum, it will reach 2, 3, 4. Because 3 other units above, 1, 2, 3. So your maximum will be at 4. And your minimum will be at what? Look at it. From here, you shift it above 1, 2, 3. It is going to stop here, right? At 2. So it means the graph will stop here and here. What will be our imaginary x-axis? Always consider this number here, 3. So this is our imaginary x-axis. There's a reason for drawing this, so that remember, if you have 0, it is to be here. So if you have 0, it will be stopped. It will be on this point. So where do we start? You construct your normal sine function between 4 down to 2 and nothing more. So you know you started from origin 0, it will be here. Then up to the maximum, you see under pi over 2, up to maximum, down to 0, then minimum, then up to 0. This is how the graph look like. You see that? The graph is supposed to be within here, but it has been shifted how many units? 3 units above. If you count, all of this will be true. Then we have another one, which is cosine of x minus 2, which is another vertical shift. Y equal to cosine of x minus 2. Pi over 2, pi, 3 pi over 2, then 2 pi. We used to have our amplitude from -1 to 1, but this time around, every single point will be shifted 2 units down. All right. 1, 1, 2. This is -2. This is -3. It means that our minimum will be at what? -3. Then this one, 1, 2. Our maximum will be what? At -1. Remember, I told you always this number should be your imaginary x-axis. So, all right. This is cosine, which used to start from the maximum. So this is now your maximum point, right? Down to 0, to the minimum, to 0, to what? The maximum. The maximum should be at -1. You see that? This is now the cosine of what? X minus 2. So I think I have shown you all the transformations. So now let's see how we can construct a function in this form. Everything will be written now. We have the first one as y equal to 3 multiplied by sine of 2x minus pi, then plus 1. All right. You can see we have minus here, right? Because of this minus, the graph will be shifted to the right. So it doesn't matter. I would like to talk about the period first before we do anything. You see we have 2 here. The period P will now be equal to 2 pi divided by that B, which is 2, and our graph will stop at pi. So I have 1, 2, 3, 4. Okay, let me make it small because I know it is going to be shifted. So 1, 2, 3, 4, this will be our pi. Divide by 4, this will be pi. Divide by 4, this will be pi divided by 2. And this will be 3 pi divided by 4, right? Okay, so this is our period of pi. Now I would like to talk about this and this together because this is going to be our imaginary x-axis, right? At 1. So we used to have 1 to -1. Normally we used to have this. But because of this number here, it will reach after 3. So it will be 2, 3, 2, 3, negative 2, negative 3. All right, we are done with the amplitude. The amplitude will stretchen the graph vertically. Then we have plus 1, which is going to shift it. Oh my God, it is going to reach after 4, because the moment you add 1 here, because this is now our maximum, you add 1, it will have to go to 4. So this is going to be our maximum, and this is going to be our minimum, because it's supposed to stop here and here. But since we have shifted the graph up 1 unit, it will stop at negative 2 down to 4. We are done with the amplitude. Then we need to talk about the horizontal shift. I started with the period by taking 2 pi divided by this, and we got pi. Next, I dealt with the amplitude by multiplying our normal period by 3, and I got 3 to negative 3. Then I added 1, I shifted the graph up to 4 and down to negative 2. We are done with that one. Then the last thing I would like to treat is the horizontal shift. So the moment you take the whole of this, you set it to be equal to 0, it will give you the, what do we call it? The shift, the number of units you're going to shift the graph. Another way you can do that mentally, you can take negative of this number, negative pi, then divide by b. Always do this. It will give you the number, which is pi divided by 2. It means we are shifting the graph pi divided by 2 to the right. It means it is going to come up to this point. So this is my imaginary y-axis, and this is my imaginary x-axis at 1. Remember, that is what I told you. If you count, it will be the same. 1, 2, 3. 1, 2, 3. You see that? This is why this is the center. So this is the point of intersection, which we are going to consider as this. No problem with that. So let me delete all of this. This is our origin, right? So all we have to do is to construct the sine function the way we used to do that. This is our y-axis, this is our x-axis, so this is the origin. At origin, we have a point on sine function. Then the next point will be after what? The maximum, and our maximum is 4. So under this, we have maximum after 4. Let me just write it, no problem. Then the next one would be after 0. This will be 0 here. Then the next one will be after the minimum. The minimum is what? Negative 2. And the last one will be after 0. So let's see how we can connect them. You see how the graph looks like? Just one period. And the graph can move on forever. Something like this. All right. This is how to transform sine function. We have extended, stretched the graph vertically. We have shifted the graph 1 unit above. We have also shifted the graph horizontally to the right, pi over 2 units. So now let us treat the last one. The last one is y equal to negative 2 cosine of 1 over 2x plus pi over 2, then minus 1. This is our last problem for today. Okay. Since this is plus, it is going to be shifted to the left. So let me give you a space. Let me come down here. All right, let me start with the period. The period will be 2 pi divided by what? 1 over 2, which is going to be 4 pi. So we are going to stop at 4 pi. 1, 2, 3, 4. So if this is 4 pi, if you divide it by 4, you have pi here, you have 2 pi here, you have 3 pi right here. If you come to the left, you have negative pi, negative 2 pi, and so on. Okay, we are done with the period. Now let us talk about the amplitude. You see this number here, -2? Take the absolute value, it will be equal to what? 2. So you multiply these two numbers by 2. It will be after 2 down to -2. So we have 1, 2. You have a -1, -2. Then -1. This is what vertical shift 1 unit below because it is minus. So every single point will be shifted 1 unit down. So we're going to reach up to -3. So this is going to be our minimum. This is initially the maximum, it will be shifted down here. So this is, remember, always, this is going to be maximum, minimum. Let me bring it here. Then what will be our imaginary x-axis? The imaginary x-axis will be what? At -1. This is going to be our imaginary x-axis. Then to determine the imaginary y-axis, let us solve this equation. You can take negative of, I told you this is a formula, right? Negative of pi over 2 divided by 1 over 2, which is going to be -pi. So it means that it is going to be shifted -pi to the left. So you see -pi here? All right, so this is our origin, the intersection between our two imaginary lines. You don't have to construct them, but I just feel like doing that so that you see where we're going to start. You see, this is cosine, right? Which is supposed to look like this. But because of this negative sign, it is going to be reflected. Every single point here will drop down here. Every point at the bottom will go up. All right, let's get started. From the origin, to construct a cosine graph, you have to go to the maximum. But from the origin, we have to go to the minimum since we have reflected the graph. And the minimum is at -3. Next point here. Next point is at 0. 0 normally doesn't reflect. It will stop at 0. The next one would be at minimum, but this time around it is going to be after the maximum, and the maximum is 1. Next one is to be 0, so it will not change. And the last one, because remember we're supposed to stop here, but the graph has been shifted to the left pi unit. So this one, the last one used to be what? At maximum, so it will be at minimum. The minimum is -3. So you see our points, 1, 2, 3, 4, 5. Let's connect them. Yep, this is how the graph looks like. Unless if you want to continue constructing the graph, you can do that, but this is for one period. As simple as that. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.